Welcome back for part 3 of the products rules of exponents, and here we'll look at negative exponents. Let's go ahead and label some stuff real quick because I forgot. This is example 1. This is problem A, and this is problem B. Okay, now we are combining the product rules with the negative exponent rules. So let's review product rules real quick. The product rule states for any a to the m times a to the n power is a to the m plus n, that's an m, and the negative exponents is for any a to the negative n equals 1 over a to the positive n. Alright, so here it says, example A says simplify 2x to the negative 1 times 4w to the ninth times 2u to the sixth times w to the negative 7 xu to the negative fourth power. The very first thing we want to do again is go through and collect our like bases. So I have x to the negative 1, x to the 1. Next, I have w to the 9 and w to the negative 7. And lastly, I've got u to the 6 and u to the negative 4. And then I've got my constants hanging out, 2, 4, and 2. Alright, so now I want to go rewrite these in the proper order. I'm going to have 2 times 2 times 4 because they're all separate from their bases. Now I'm going to rewrite all of my bases. So I have x, which is going to be times x to the negative 1 times x, and this is a 1, a little 1 up there, times x to the 1 times, we've got w, so we have w to the ninth power times w to the negative 7 times u to the sixth times u to the negative 4. Alright. Now, my advice for these negative powers is to apply the product rule first to create, or to help us from creating any unnecessary flipping due to the negative exponent rule. So, always do the product rule first, apply this last. So we'll do 2 times 2 times 4, so 2 times 2 is 4, times 4 gives me 16, times x to the negative 1 plus 1 times w to the ninth plus negative 7 times u to the sixth plus negative 4. Now I just have to go apply my integer rules. So I have 16x negative 1 times 1, negative 1 plus 1 is 0, so I have x to the 0, which we'll talk about in a second, times w, 9 plus negative 7, 9 plus negative 7 gives me w squared, times u to the 6 plus negative 4, so 6 plus negative 4 gives me 2. So in this situation, I don't even have to use my negative exponent rules. So this is what we want to apply first. This is what we want to apply second or last. So I'm going to say last. Okay, now x to the 0 equals 1. For any a to the 0 power, we get 1. So this guy goes away. 16 times 1 is 16 times w squared u squared. Okay. Seems long and complicated, but really all we need to do is keep track of our negatives and we're golden. Let's go check another one real quick. I've got 2w to the fifth u times 4x to the negative fourth x to the fourth times 6u to the negative 7 w to the negative 7. So let's go organize this beast. I've got w to the fifth power. Nope. W to the negative fifth. Let's predict what's going to happen to these. Go ahead and predict it, and then we'll talk about it, our prediction. Next, I have u to the 1. Let's add a little 1 up there. And u to the negative 7. And then, lastly, I have x to the negative fourth, x to the fourth. And we can almost predict what's going to happen to the fifth and the negative fifth and the negative fourth and the fourth power. So I'm going to go rewrite this and collect my variables 2 times 4 times 6, collect my constants 2 times 4 times 6 at the front, times, I've got w to the fifth, times w to the negative 5, times x to the negative 4, times x to the fourth, times u to the 1, times u to the negative 7. This all reduces down, so we have let's go this way. 2 times 4 is 8, times 6 is 48. W, 5 plus negative 5. Guess what's going to happen here? X to the negative 4 plus 4. Guess what's going to happen here? U1 plus negative 7. This part's something we haven't seen before. So we'll end up with 48 W 5 plus negative 5 is to the 0 power. X negative 4 plus 4 to the 0 power. Looks like a little 6. And then times, so we got times u to the negative 6 because 1 plus negative 7 is u to the negative 6 power. Alright, now lastly, remember that these go away, they become 1s. So 48 times 1 is still 48. But I need to fix this u to the negative 6 power. So this is my a to the n rule. So I need to change it to 1 over u to the 6. And this equals 48 over u to the 6th power. Go ahead and try problem B on your own, and we'll check it in class tomorrow.